So let's continue with our Code Maven tutorials. This is where we left off last time. And we have the spinning boxes. And this is the beauty of using objects. Because with objects, you can just keep repeatedly using the code. And even though there are different values for each of these boxes, they're spinning different ways, they start in different positions, they're going in different directions. The way they're updated is all the same. And all we have to do is, down here, control the number of boxes that we want to do. So like here, for example, we've got 3 boxes. I could do 13 boxes if I want. And just like that, we are using objects to multiply these spinning boxes. Now, since all of these boxes correspond to variables, that's an important thing to remember, is that that's what an object is. An object is something that is defined as far as the information a thing has, the functions a thing performs. Okay, but each new object that you create belongs to a variable. Okay, so let's look in line 64. Boxes.push means we are creating a new box. It's the same as creating a new variable of type box. And that box is going to have the parameters here in parentheses. Okay, so the actual creation of the box does not happen until line 64. And when it happens, all it does is it follows the recipe for a box. And the recipe for a box is defined in lines 1 through 38. So lines 1 through 38, that whole top chunk of the program, is just defining the box object. All right, so what she says here is one thing is new. When the box checks if it is off the screen, there's something you haven't seen before. The double parallel lines, or the double bar. Okay, that means or as in either or. So the first if statement checks if the box has either gone off the left or right edge. The second checks if it has gone off the top or bottom. You see, one or the other is going to be true. And if one or the other is true, the whole statement is true. Okay, that's different from and. When you have two conditions and you put and between them, both have to be true for the combined condition to be true. With or, only one of them has to be true. And that's what's going on here. There is also a way to say and, as in both have to be true, which is double ampersand. That's what that symbol is called, ampersand. So double bar means or, and double ampersand means and. Back to the fun. Have you tried putting in a lot of boxes yet? Try it. Make it so there are 10 boxes or 50. All right, well, that's easy to do. We just go down here and we change the number of boxes. So we can make it 10. So we just go here, change this to 10. Or we can make it 50, like she says. And notice that every box is behaving exactly the same way. Yes, they are all at different angles. They start at random angles. They start at random positions. They have random speeds, but they all are behaving in a similar way because they all are defined by the same box object. See how easy it is to keep track of all these boxes, their position, angle, velocity, and everything else using objects. Once you say what a box object is, it's easy to create lots and lots of them. And that, by the way, some of you have asked me, what's going on with this? Well, all right, think of it this way. What's happening is the entire screen is being updated many times per second. And to see exactly how many times per second, you just go to line 40 here. And this time step equals 50 means that every 50 milliseconds, everything is being redrawn, right? And this happens so fast that our eyes don't perceive the flashing. Our eyes don't perceive that the entire screen is getting erased, and then every single box is getting redrawn. Now, the thing is, every single box is getting redrawn one at a time. This is what you don't perceive when you're looking at this animation. It looks like everything's just happening at the same time, but that's an illusion. That is an illusion. Everything is happening one thing at a time. Hey, look at this for loop down here. Um, this for loop down here for var I equals 0, I is less than 50, I equals I plus 1. All right. Well, this is creating a new box every time it goes through the for loop. And it's going through this for loop 50 times. Well, every time through the for loop, it creates a new and unique box. Okay, and it has to do that one at a time. Now notice that also happens here in the update. So lines 45 to 49 here. Actually, it's more than that. Lines 45 to 52. This is the update all function. And the really key step here is in lines 47 to 48, because in this for loop, you see, in this for loop, what you have going on is that one at a time, every single box is getting redrawn. And what does boxes I dot update mean? Well, we've got 50 boxes. So that means that there's boxes 0, there's boxes 1, there's boxes 3, there's boxes 10, there's boxes 49, there's boxes 35. Every one of these boxes is a unique variable, a unique variable. So what is this about? Well, see, this box is operating, this box thing is operating only for the particular parameters that are sent to it for the particular box that we're dealing with. This box, okay? And it's doing this box one at a time. This box might be box 3, and then the next time, this box might be box 49, and then the next time, this box might be box 35. Of course, it's doing it in the order of the for loop, but that's what this means, okay? That's exactly what this means. And notice that this update function, okay? The update function is right here in lines 10 to 26. The update function is contained within the definition of a box. And when update is called, okay, let's look at where update is called. Update is called right in line 48. And so line 48 says, okay, let's update box 0. And then the update function runs for box 0. And then next, it says, well, let's update box 1. And then this becomes box 1. And then later on and so forth, it says, oh, let's update box 11. And then this is now box 11. See, that's the thing to remember about how objects work and how this works. This simply refers to the fact that every single box is being done one at a time, and this is happening every 50 milliseconds. You're nearing the end of the lessons now, but I still have a couple fun things to show you. Now that you know about objects with velocity, we actually are really close to being able to do cool things like make a ball bounce. All we need is a little physics, some acceleration to go with our velocities. Here's a ball object. It's a lot like the box object you saw before, but has differences. Take a look at the code. Okay, so first we're going to talk about how the code's slightly different here from the boxes stuff, and then we're going to talk about the physics thing. Now, for simplicity's sake, this code here is doing only one box. And we see that because it's just, look, I is less than 1 in line 48. It's only one box. When there's only one box, well, using this doesn't really make that much sense because, you're not saving any time. But when you have multiple boxes or many boxes, that's when using objects and this does save time. Okay, but let's look at the differences between the ball and the box. We'll see some differences here. For one thing, there's no angle. And of course there's no angle because, if this ball were spinning It would just look like a circle, so there's no need to have an angle. Here's another important difference down here. Look at how this is being drawn. C dot arc. This is how you do an arc. And I'll explain that arc thing in just a second. So one big difference is that a ball is round, angle doesn't matter. Another big difference is that we use arc to draw circles. Arcs are cool, but they're a little complicated for just drawing a circle. Let me explain how they work. To draw a circle in JavaScript, you call c.arc xy r0 math.pi times 2, where xy is the center of the circle, r is the radius, and then 0 and math.pi times 2 says to draw an arc from 0 degrees to 360 degrees. And this is all because 360 degrees is the same as 2 pi radians. Now, I did briefly explain radians in degrees before, we all left school in March. But just as a quick review, pi is equivalent to 180, pi over 2 would be 90, pi over 4 is 45, 2 pi is 360. Now, we don't have to make a full circle though. Look at what I do here. So what I'm doing here in line 26 is I'm getting rid of the times 2. And now I have what looks like a smiley, and that's because I have drawn only half a circle. Okay, well, I could draw a quarter of a circle, because a quarter of a circle would just be equivalent to 90 degrees, and that's pi over 2. So math.pi over 2 gives me that arc right there. All right, well, let's go back to circles though. Okay, so 2 pi. And this is how circles are drawn. Because we draw circles from the center, a bunch of other things change, such as exactly how we check whether we need to bounce off the sides. Take a look at the code again. Does it make more sense now? Okay, so let's look at the bouncing part. Bounce off the edges. Before, we had to worry about the size of the box. Okay, but now the size of our ball is defined by its radius. So that simplifies how we check. So this dot x minus this dot r less than 0. So that would mean that if you're all the way far left and half a circle, which is 1 radius, has to fit. So this dot x minus this dot r has to be less than 0. And if it is, that means it's time for a bounce. Or how about when this dot x plus this dot r is greater than width? Well, that means it's going to be off the canvas on the right-hand side, and it's time for a bounce. As you can see, the bounces work similar to how the box is bounced, but they're just a little different because instead of size, we're using radius. Okay, now we want to make a bouncing ball. To do physics, we need velocity and acceleration. So far, we have had velocity, but no acceleration. Let's add acceleration. Here it is. All right, now before I explain acceleration, I think it's important to re-explain velocity. Okay, and velocity is entirely here in lines 5 and 6. Velocity is dx and velocity is dy. Now we saw a little bit of this in Python when we started to do moving objects, and the amount that you change it horizontally, the amount you change it vertically. Well, it's the same exact thing here. Okay, think of dx as difference in x coordinate. Think of dy as difference in y coordinate. And now you might be thinking, well, how is a velocity a difference? Well, a velocity is always a difference in how much distance there is per unit of time. Okay, so let's say you're going 20 miles per hour. That means in 1 hour, the difference in your distance is 20 miles. Well, let's say you're going 40 miles per hour. That means in one hour, your difference in distance is 40 miles. Same thing here. Maybe dx is 10 pixels. Okay, if dx is 10 pixels, that means that it's going to scoot over to the right or left 10 pixels. Or maybe dy is 5 pixels. That means it's going to go up 5 pixels or down 5 pixels. Each time things are redrawn. Okay, each time things are redrawn would be the unit of time. You define that. Maybe it's every 50 milliseconds, maybe it's every 20 milliseconds, but whatever it is, there's a set unit of time for which all objects that are being animated are redrawn. dx and dy just tells you what the difference will be horizontally and vertically each time the redrawing happens. Okay, so that's how velocity works. Well, acceleration is similar. Now, um, let's just talk about acceleration as a physics concept first, before we go on to how it works in code. Okay, let's follow the motion of this ball. This might remind you of the last challenge we did in bat and ball with Python. Okay, notice how the ball slows down as it goes up. It speeds up as it goes down, slows down as it goes up, speeds up as it goes down, slows down as it goes up, speeds up as it goes down, slows down as it goes up, etc. Okay, well, we tend to think of acceleration as just speeding up. That's actually not what it means. What acceleration means in physics is that the speed is changing. That's all it means. The speed is changing. And if you follow this ball as it's going up and down, we can see that its speed is constantly changing. Whether its speed is decreasing as it goes up, or its speed is increasing as it goes down, the fact remains that its speed is constantly changing. It's constantly changing. Now, this happens in line 19, okay? Because in line 19, this dot dy plus equals gravity just means that every time we're updating the function, whatever the difference in y was, maybe it was 5 pixels. Okay, it was set to go up or down 5 pixels. Okay. Well, notice that gravity here is 0.05. So that means that 50 milliseconds later, dy is not going to be 5, it's going to be 5.05. And then 50 milliseconds after that, it won't be 5.05, but it'll be 5.1. 50 milliseconds later, it'll be 5.15, etc. Now, this is happening many times per second, and so that 0.05 is actually enough to cause a significant slowdown or speed up. Now, what's the plus equals doing here? Well, think of it this way, okay? When we're doing JavaScript, the origin is here at the top left corner. And here at the top left corner where I'm hovering, that is coordinates 0, 0, which means that as 0 gets more positive, sorry, not as 0, but as the y coordinate gets more positive, the y coordinate is going down. In math, usually, we think of negative as going down. Well, it's different here. Positive means going down. So this plus equals in line 19 means that there's a constant tug in the downward direction. If this dot dy is negative, meaning it's going up, well, then that positive tug is going to make it slow down as it goes up. If dy is positive, which means it's going down, well, then this plus equals will reinforce that downward movement, and it's going to speed up. So that's how gravity works, and that's how we see this cool simulation of the up and down bouncing motion. See it. Now every time we update on a ball, we change the downward velocity, dy, by whatever gravity is. Well, let's change gravity. Let's see what would happen if we go down here and, okay, let's say, so this is every 25 milliseconds. Let's say that we want gravity to be a little stronger. Okay, well, let's try 0.1. Go to 0.1. Okay, we can definitely see a difference here. We can see that gravity has a more pronounced effect. How about 0.2? Even more. How about 0.3? Even more. How about 0.5? Even more. quite a bit. How about 0.7? Quite a bit. Okay, well, the point is that all gravity here means is it is how much the vertical velocity or the vertical dy changes every time the updates happen. Pretty cool. Try adding 10, 15 balls and watch it for a while. It's a full physics simulation with gravity and bouncing. Very fun. Okay, well, let's see. Let's put gravity back to something a little slower. So I'm going to just put it at 0.3. And now I'm going to add to our number of balls. So let's do 10. So now I have 10 balls that are all starting at random positions, and they are all bouncing. And they're bouncing according to the acceleration provided by gravity. Let me show you one more thing before we move on from bouncing balls. This is called a partially elastic collision. Okay, so a fully elastic collision is when velocity is conserved, right? Kinetic energy is conserved so that after a bounce happens or after a collision happens, the object has the same speed as it had before. That speed might be in a different direction, up versus down or down versus up, but it's the same magnitude. With a partially elastic collision, um, something gets lost to friction, and that's what we have here. Think about if you have a bouncy ball and you drop it from 10 feet. Well, even the best bouncy balls are not going to reach a height of 10 feet. They might reach, 9 something, and then they bounce again, and maybe they'll reach 8 something, and so on and so forth. And that's because some energy is lost when it hits the ground. It's not a perfectly or fully elastic collision. It's partially elastic. Now, how do we do this in code? It's simple. If we didn't put times friction here, this dot dx equals negative this dot dx means if it was going left, it's now going right. If it was going right, it's now going left. But the times friction means that instead of switching its speed, switching the direction of its velocity, instead of doing that at the same magnitude, it's doing that at less. Okay, so let's say that I crash into the right-hand wall at 50 miles per hour in a bumper car. If that were an elastic collision, then I would bounce left also at 50 miles per hour. But no, this is not fully elastic. So if I hit that right-hand wall, 50 miles per hour in a bumper car, I'm going to bounce back to the left at maybe 40 miles per hour. Okay, something is lost. And that loss is reflected in the fact that friction, which I'm showing you here in line 37, friction is fractional. Friction, fraction, friction, fraction. Friction is fractional, and that fractional nature means that we're not getting the full amount back. We're only getting a partial amount back. In the real world, when things collide, they usually bounce off each other slower than before. That's why when you drop a ball, it doesn't keep bouncing forever. If you look at the code and update, there is now a friction force applied when the balls bounce off the walls. It makes them bounce off slower than they came in. Eventually, the balls all stop bouncing and slowly roll along the bottom. Cool simulation and add some realism. Play with it a bit. Change the friction, add more balls, increase gravity, change time step, try messing around with it. All right, well, I'll leave the messing around to you. You should mess around with it because that's part of learning. Mess around with everything. But what I've tried to do in this tutorial is explain some of the questions that some of you have posted about stuff like this and velocity and gravity and friction.